My dear children, today I am trying to solve one problem from physics, the electricity portion. So hope you are all busy with your board exam preparations. So let us try to read this particular problem, and probably some of you must have done this particular problem in the examination. But anyway, this will be useful for you, I guess. Two metallic wires, A and B of the same material, are connected in parallel. So there are two wires are available. One is denoted by A, the other one is B. Wire A has the length of L and radius R, whereas wire B has a length of 2L and radius 2R. So the length and radius of A and B are not the same. Exactly, the length of A is half of B, or the length of B and radius of B is double of A. Then it is required to calculate the ratio of the equivalent resistance in the parallel combination and the resistance of the wire. So before we start solving this particular problem, let us try to analyze the problem. So what we understood from the problem, that there are two wires, A whose length is L and the radius is R, and the other wire, which is B, whose length 2L and radius 2R. So what the examiner wants from you is to find the ratio of the equivalent resistance in parallel, which means that A and B, they are connected in parallel. They are both A and B are made up of the same material, having different dimensions. So what is required for us to calculate is to find the equivalent resistance in parallel combinations of A and B. We have to consider, or we have to represent as a fraction of the resistance of wire A. So let us try to visualize this particular problem. Then we will have something like this. We have a wire A whose length is L and radius R, and we have wire B whose length is 2L and radius is 2R. So supposed to be this, the second wire supposed to be thicker than the first wire, and of course the second one is having a length which is double of that of the resistance A, or the wire A. Let us assume that the resistance of the wire A is RA, and the corresponding value for B is RB. So as you have studied in the theory, we know that the resistance of a material is calculated by the equation rho L divided by A, where R is the resistance of the material in ohm. Rho is the specific resistance or the resistivity in ohm meter. Length in meter, and A is the area of cross section. So if you look at a circular conductor having a radius R, then A, the area of cross section, can be calculated by the equation pi R square. And if we want to calculate the same thing in terms of the diameter, the equation is going to be pi d square divided by 4. So using the above relation, we can find out the resistance value of the first wire. RA is equal to rho L divided by AA, where A is the area of cross section of wire A, whose radius is already given R. So we can use the relation rho L divided by pi R square. That will give us the value of resistance RA. In the similar manner, we can also find the value of RB. RB is equal to rho L divided by AB, where A is the area of cross section of B. So we know that the length is double, so rho into 2L divided by pi times area is equal to pi r square. Here again the radius is 2r, so we will find the radius supposed to be 2r square in this case. So if we simplify the relation, we will get half rho L divided by pi r square. Now if you compare the relationship between the two equations 1 and 2, we can establish a relation that RB, the value of RB, the resistance of wire B, that is equal to RA divided by 2, because in this particular equation rho L divided by pi r square is nothing but RA. So the RB is RA over 2, or half of RA, or RA is like what? Twice of RB. So in the given question, it is already mentioned that these two wires, they are connected in parallel. RA and RB, they are connected in parallel. So we'll try to find out the equivalent resistance when two resistors are connected in parallel. So as you know, 1 by RQ, the R equivalent is equal to 1 by RA plus 1 by RB. So in this case, let us consider the value of resistors in terms of RA. So the first resistance is going to be RA and the second resistance is going to be RA divided by 2. Or it's the same question can also be addressed, like in terms of RB. So if you are going to look at RB, then the one of the resistor, the bottom resistor will be RB, whereas the upper resistor RA is supposed to be 2RB. Now 1 by R equivalent equation can be further simplified by using the LCM rule RA plus RB. So the 1 by R equivalent is equal to RA plus RB divided by RA times RB. So if you substitute the value of RA and RB, so we can calculate the value of R equivalent, RA multiplied by RA divided by 2 divided by RA plus RA divided by 2. So the numerator term RA square divided by 2 and the denominator square is going to be 2RA plus RA, which is going to be 3RA over 2. And if some of the common terms will cancel, we'll get RA square divided by 3RA, or we can simplify that R equivalent is equal to RA divided by 3. So now we can redraw the diagram using a single resistor, which is the R equivalent, which is nothing but RA divided by 3. So now let us try to find out what is the final step of our problem. So this is R equivalent divided by RA. We are supposed to calculate the equivalent of the resistor. We have to represent as a fraction of what we call RA. So we have to represent as a ratio of R equivalent with respect to RA, R equivalent to RA. So this is nothing but RA divided by 3 divided by RA, and RA get cancelled. So we will get the answer R equivalent divided by RA is equal to 1 by 3. So now the same question you may also expect in other way, like the R equivalent to be represented in terms of RB. In such cases, what you have to do, you have to find the equivalent value in terms of RB. So if you just try to redraw the circuit based on RA, so RA will be 2RB and this is supposed to be the down resistor will be RB. So RA is equal to 2 times RB. Then R equivalent can be calculated by the equation R1 R2 divided by R1 plus R2, which is 2RB times RB divided by 2RB plus RB. So if we simplify this, we will get 2RB square divided by 3RB, which will be 2 by 3 RB. Now, and sometimes the examiner can ask the question like this, R equivalent with respect to RB, then if you calculate, you will find the value which is equal to 2 by 3. Hope you have